Hi, and welcome to 6.2 Independent Practice. This is all about this is about one-step equations. And here we go. Without further ado, I'm going to do all the problems from this. And here it says the table shows the elevation in feet at the peaks of several mountains. Use the table to write and solve an equation for numbers 7 through 9. So we're going to write an equation first. And here, Mount Everest is 8,707.37 feet higher than Mount McKinley. What is the elevation of Mount Everest? Well, what we got is we have this elevation of 8,707.37 feet, and that's the height of Mount Everest, and that is, which is, write the equal sign whenever you see is, and that's that many feet higher than Mount McKinley. So Mount McKinley is 20,321.5 feet. What's the elevation of Mount McKinley? So if you take some height and you subtract Mount McKinley, you end up with the height of Mount Everest. You see. So take this, because this is higher. So if you take some height and you subtract that, you end up with that. Okay, so we've written the equation. And let's go with the solution now. So you have x minus 20,321.5 feet is equal to 8,707.37. So to solve the equation, you have to use the inverse operation. 321.5, 20,321.5, and you were adding these together, so that ends up being 29,028.87. Yes, 0.87 feet. So it's 29,028.87 feet. Okay. Liam descended from the summit of K2 to an elevation of 23,201.06 feet. What was his change in elevation? Well, let's look at K2. And K2 is 28,500. Oh, goodness. These huge numbers. K2 is 28,251.31 feet. And she descended, so that means she went down. How far did she go down? We're trying to figure that out, so that's x. That's how far she went down. And then she ended up at this elevation of 23,201.06 feet. So there's our equation that we created. Now we have to solve that equation. We have 28,251.31 minus x is equal to 23,201.06. Okay, so we need to subtract the 28,251.31 from both sides. Negative 28,251.31. Whew. What we're left, these cancel, and what we're left with is negative x. And we need to subtract these two numbers here. But I need to put the 28,000 on top for a moment. Now, my answer is going to, this part's going to be negative. Oops. This is going to be negative because 28,000 is bigger than 23,000, so it's going to be negative. But I have to still, for a moment, take 28,251.31 minus 23,201.06. And I got to subtract. So what? That's 5, that's 2, that's 0, 5, 0, 5. So I believe it's 5,000. 0.25? Yeah, 5,050. So that's negative 5,050.31 0.25. And that would be almost the answer, because we don't want to know what negative x is. We want to know what regular x is. And here is a simple rule. If you change the sign on one side of the equal sign, you have to change the sign on the other side of the equal sign. So that would be 5,050. I'll put a comma there, 0.25. And there you go. There's the answer. X is equal to 5,050.25 feet. Okay, let's go on to the next. K2 is 11,194.21 feet higher than Mount Kenya. What is the elevation of Mount Kenya? So, what this is K2, the height of it is 11,194.21. That is, right? So there's our is. And we need the height of K2, which was 251.31. So K2 is higher than that. How much? It's 11,000 feet higher. So what is the elevation of it? That means that we have to subtract x here to figure that out, and x will be the elevation of Mount Kenya. So when we solve this, I'll show you here. These huge numbers are so tough. You know, there's 28,251.31 minus x is equal to 11,194.21. That was our equation taken from there. And we need to subtract 28,000 just like we did before. Subtract 28,251.31. And these cancel. We have negative x again. And we have to subtract with 28,251.31 on top because it's a bigger number. 11,194.21. Subtract, it's 0, 1. 11 minus 4 is 7. This is now 14 minus 9 is 5. That's going to be 0. This is 7, and that's 1. So it's going to be x is equal to... Oh! So this is negative because it's negative because 28 is bigger than 11, and so it's going to maintain that sign there. 17,057.10. But like I did earlier, I'm going to erase this stuff here so you can see all this better. If you if you change the sign to positive, then you have to change the sign on the other side also. So that would be now positive 17,057.10. So x is 17,057.10. Oh yeah, and feet. All right, hopefully that's the end of those big numbers, you know. Hot air balloon begins its descent at a rate of 22 and a half feet per minute. How long will it take for the balloon's elevation to change by 315 feet? Well, it descends, so it's 22 and 1/2. It descends, so it's negative, times something, so many minutes, will equal negative 315 feet. Let's solve this. Let's solve this over here where we have negative 22 and 1/2 times x equals negative 315. So let's turn this into an improper fraction. Make it a little bit easier. So 2 times 22 is 44. Plus 1 is 45 over 2. It's negative. Let's put the negative in the denominator. And times x equals negative 315. So now what we have to do is we have to multiply by the reciprocal. I'll move it over a little bit. So the reciprocal is flipped over, negative 2 over 45, and I have to do this times negative 2 over 45. These cross cancel. That's what you're going for, and you get x is equal to. And 315 times 2, negative 315 times 2 is 630. So that's 630 divided by 45. That's going to be 14, I believe. So yeah, that's 14. So it's going to be semicolon 14. Let me bring this over here more. 14. Oops. 14 minutes. That's how long. Number 11. During another part of its flight, the balloon in exercise 10 had a change in elevation of negative 901 feet in 34 minutes. What is its rate of descent? Well, what you would do is you would take negative 901 and divide it by 34. Let's see. That is, how many times does 34 go into that? Let's see. 34 goes into 901. Doesn't go into 9, but it goes into 90 twice, which is 68. That's 2. That's 22, 221. And I think that goes in 6 times. So that's 4, 2, 18, 19, 20. And that's 11 minus 4 is 7. That's going to be 1. And that's it. So it ends up being, this right here is the 26. This is the numerator. Over 34 is the denominator, which is equal to 26. 17 goes into 34 2 times, so it's 26 and 1/2. Yeah, 26 and a half feet per minute, right? It's a rate. So 26 and a half feet. See, this was feet and this was minutes. So the rate then is 26 and a half feet per minute. All right. Number 13. 13. Whew, look at that. There's a lot going on there. And here we have the table shows the average temperatures in several states from January through March. Use the tables to write and solve an equation for numbers 12 through 14. So what we have here is we have the few states here: Florida, Minnesota, Montana, Texas, and these temperatures. How much warmer is Montana's average 3-month temperature than Minnesota's? So we have, we got Montana's here. That's negative 0.7. So I'm going to write that down, negative 0.7. And so how much warmer is that than Minnesota's? And Minnesota's is negative 2.5, which is definitely colder. And so it's colder, so we have to subtract something to get to there, and that difference is how much colder it is. So let's solve that equation. We have negative 0.7 getting colder minus x is equal to negative 2.5. Okay, so we want to get x by itself, so let's add 0.7, those additive inverses there. So adding 0.7, and you do it to both sides of the equal sign. These cancel. We have negative x is equal to, now these are two different signs here, so you have to subtract them, and there's more negatives than positives. So this is going to be negative, and I'm going to subtract them. 15 minus 7, and the bigger number's on top, so that's great. So 15 minus 7, so this would be 15, and this is now 1. So 15 minus 7 is 8, and I have 1.8. So I have negative 1.8. but that's negative x. See, I don't want to know what negative x is. I want to know what regular x is. So if I change the sign on this side, I have to change the sign on the other side. So it's going to be 1.8 degrees Celsius, because it's all measured in Celsius. That's what it shows up here. And warmer. So let me move. Oh, I can't move it. I'll have to write right here, warmer. So 1.8 degrees Celsius on average warmer. So next, how much warmer is Florida's average 3-month temperature than Montana's? Well, Florida is 18.1 degrees Celsius. And how much warmer is that? Well, it's warmer, so let's say, let's take off something here to get to that Montana's temperature of negative 0.7. So how much warmer? So it's warmer, that means something has to go down to reach the Montana's temperature. So I'll write that down here. That's 18.1 minus x is equal to negative 0.7. And we have minus 18.1. These cancel. I have negative x is equal to, these are the same signs, so I'm going to add them up. That's going to be 0.881. And they're all negative, so it's negative. Now, again, I have what negative x equals. I want to know what regular x equals, so that if I change the sign there, I change the sign on the right-hand side, 18.8. And so it's going to be 18.8 degrees Celsius warmer. Next, how would the average temperature in Texas have changed? How much would the average temperature in Texas have had to change in order to match the average temperature in Florida? Well, the average temperature in Texas is 12.5 degrees. And it would have to, and in Florida, it's 18.1. So it'd have to get warmer, so let's add some degrees there. So add how much? Let's find out. I'm going to erase all this stuff here, so I have some room. And so I have 12.5 plus x is equal to 18.1. You got to subtract 12.5. So these cancel. I got x. And these are different signs here. Oops. These are different signs, so I get to subtract. It's going to be positive because 18 is bigger than 12. So I subtract, that's 11. So that's 6. This is 7. This is 5. And that's 0. So 5.6. So it would increase. It would increase by 5.6 degrees Celsius. Okay. Let's go on to the next one. A football team has a net yardage of negative 26 1/3 yards in a series of plays. So that net yardage means they go forward some, they go backward some, and overall they've gone backwards 26 1/3 yards. Not so good. The team needs a net yardage of 10 yards to get a first down. How many yards does the team have to get on the next play to get the first down? So let's see. They have negative 26 1/3. They need to add something to get to 10. Let's add 26 1/3. This is going to be easy. X is equal to 10 plus 26 1/3 is 36 1/3 yards. So 36 1/3 yards. Okay, on to the next problem. That's for the next page for you. And it says here, a diver begins at sea level and descends vertically at a rate of 2.5 feet per second. How long does the diver take to reach negative 15.6 feet? Well, it looks like we need to say, let's see, descends, so that means goes down 2.5 feet per second. So how many seconds to reach negative 15.6 feet. I think I need to solve this over here. So negative 2.5. Negative 2.5, let's see, 2 times 2 is 4 plus 1 is 5. So that's negative 5 halves times something equals negative 15.6. Let's go with the reciprocal. We did that before, so 2 over negative 5. If we multiply by the reciprocal here, we have to multiply by the reciprocal here, 2 over negative 5. These all cross cancel, and x is equal to, we multiply 15.6 times 2, which I think is 31.2. Yeah, that's negative 31.2 divided by negative 5. And I have a little calculator over here. I'm just going to check myself. So 31.2 divided by 5 is 6.24, and that's it. Negative divided by negative is positive, so it would be 6.24. So it ends up being 6.24 seconds. Okay, next, number 17. In exercise 16, what is the relationship between the rate at which the diver descends, the elevation he reaches, and the time it takes to reach that elevation? Well, that relationship is the elevation is the product of the rate and the time. See, the elevation, which is this, is a product of the rate, which is 2.5 feet per second, and the time. So that product makes the elevation. Okay. We have number 18. Jane withdrew money from her savings account in each of 5 months. The average amount she withdrew per month was $45.50. How much did she withdraw in all of the 5 months? Show your answer is reasonable. Well, let's see. She withdrew 5 month average month. How much? Well, it basically would be she withdrew for 5 months, $45.50. And that product is, I'm about to multiply it, 5 times 45.50 is $227.50. So how do we know this is reasonable? Well, if I just call it, instead of 5 times 45.50, that could be, it could be negative 5 times 50. Instead of 45.50, how about just round it to $50, which is equal to negative $250, which is close to the real answer of 227.50. Yeah, it's not too far off there. Yeah, you're comparing that rounded answer to the actual answer. It's reasonable. Let's justify our reasoning. Consider the 2 problems below. Which values in the problems are represented by negative numbers, and explain why. So we have a diver below sea level ascends 25 feet to a reef at negative 35.5 feet. What was the elevation of the diver before she ascended to the reef? And a plane descends 1.5 miles to an elevation of 37.5 miles. 3.75 miles. What was the elevation of the plane before its descent? So if we look at this here, which values are in the problems are represented by negative numbers? So here is below sea level. So what's represented by negative numbers? The elevation of the diver and the reef. The diver is below sea level, so that's going to be negative 20. The diver's below sea level, so his elevation is negative, and the reef is at negative 35.5 feet, so that's represented by a negative number. So both of those are negative numbers. The other one here, so what's represented in the second situation? Well, the plane descends, so the plane's change in elevation, that's represented by a negative number, because was represented by a negative number. And what was the plane's elevation of the plane before its descent? So also, the plane is moving from a higher to a lower elevation, so that descent is represented by a negative number. Let's look at number 20. How is solving negative 4x equals negative 4.8 different from solving negative 1/4 x equals negative 4.8? How are the solutions related? So what you got here is, in the first case, so this first equation, you divide both sides by negative 4. See, that's multiplication right there. So you have to divide by negative 4. So to solve this one, so as I move this aside here, if we have negative 4x equals negative 4.8, you would divide both sides by negative 4. See, that's what I'm talking about. Now, in the other one, let me move this here. In the other one, in the second, you multiply both sides by negative 4, or divide by negative 1/4, same kind of thing. So I'll write that here and show you. That would be negative 1/4 x equals negative 4.8. So you would multiply, if you multiply this by negative 4, then negative 4 is the same thing as negative 4 over 1, then these would cancel. See, multiplying by negative 4, and then you multiply this by negative 4, or negative 4, negative 4, then that would solve that. And so this is equal to 16.2. I'm sorry, 16.2, not 16.2. 19.2, which is this right here. And then in the other one, this is equal to 1.2, which is this one. Okay, our last question here. Flynn opens a savings account. In 1 3-month period, he makes deposits of $75.50 and $55.25. He makes withdrawals of that much and that much. His balance at the end of the 3-month period is that. Explain how you could find his initial deposit amount. So here's the response. So what do? You add the deposits and the withdrawals. You let X represent the amount of the initial deposit. So we'll write and solve the equation. That initial deposit plus the deposits minus the withdrawals is equal to that final amount, $210.85. So there you go. There it is, up and down. I hope this has been helpful. Thanks for watching. Bye.